Okay, so this particular exercise show how to join 4 tables. I'm going to change this a little bit and to see how can we do this. So now instead of give you manage SSN, I'm going to give so SSN, I'm going to give you manager's last name. So give you last name of Smith. Let's see how to do this. So no, this is not available anymore. Instead of last name of the managers given. So let's see how to do this. I give you 4 minutes on this. Another in-class exercise. You can work on top of this. 4 minutes, okay? Okay, so now let's see how to do this. So the only thing changed here is we have last name, right? And how can we get last name? It's coming from employee table. However, be careful when you do this. This is the employee actually work on the project. It's not necessarily the manager. And most likely they are different person, right? So what we can do is I need another employee, and that's actually the manager, right? The manager with last name here. And now we have 2 copies of employee. What can we do? And we did this very similarly for the supervisor example. So I'm going to give 2 copies of it. And so the first copy as E, for example, and the second copy as M, like manager, for example, like this. And so now we solve the problem. I can have 2 different copies. And for the works on table, project table, and department table, you don't need to use alias like E and M. You have to here. And you don't need to use it. But as I said, you make people feel more comfortable if they use in all of them. Again, this is optional. So, but let me put this on. Works on and that's P, right? And last one as D. Okay, no space. Okay, come on. Okay. Department as D, comma. Okay, all right, make it. So this way we be able to restrict. So the whole thing is just because I needed this E and this M here. So now I can modify this. And so let's see, this SSN is coming from, let me use in different colors so you'll be able to see clearly. So this SSN is coming from this E, okay? It's not coming from manager. And this is coming from W. And this PNO is coming from W. And this is coming from project P, right? Okay, and this is coming from P, and this is coming from D, right? So far everything's restricted. This is the only one. This is the only one that is required to be restricted. Other things, they are optional. And I need to add one more. That is, the last name is Smith. So this last name is coming from manager, right? And so when you do this, you will see I actually have to do something between this department and this manager M, right? Okay. Of course, the last name is one thing. Actually, I'd be able to put the last name firstly. So last name equal to Smith. So I can put this one in for sure. But we do need something to make the department and the employee as manager related. And that is we need to make SSN equal to manager SSN. So departments, so this is the department. sometimes when you have complicated one, the alias actually helps. So this is coming from department manager assistant is equal to this manager M dot managers assistant here. So you see this M assistant and E assistant, they are two different things. This is simply run back to the employee table means that's my manager here. Okay. So now I have everything. And when I do this, right? This is supposed to be, did I remove this by any chance? So I probably forgot to put it out here. So this is the last name. And now I need to restrict the last name is coming from where, because this one has last name, this has last name. So we have the employee's last name, and this is coming from employee here. Okay. Okay, so in this case, remember we talked about two different approach to restrict them. In this case, you can only use alias to solve the problem. So this is very similar to the supervisor example. For the employee table, we have two different copies. This one serves as the employee, and this one serving as a manager. So they serve different roles. Okay, it is wrong to use employee dot last name here because we still have ambiguity. We don't know which copy you are using. Okay. All right, so that's for this one. Hopefully a good exercise, right? To see, you know, this is kind of complicated to go through things, you go back, but good exercise to see if you understand the logic for using alias or not. Okay, so now we can move on to finish this, finish that. Okay, so now let's move on to the next topic is using set operations. So the things we covered so far is one single block using select from where clause, right? Okay, so what happened if I have a two query result? So I have this one, I have another query with a select from where. Can I combine the result together into a new result or not? Okay, this one actually quite useful when you're working on, say, two different data sets, okay, and the two different tables, and they have something really common. And sometimes you want to combine them together to do certain analysis. And so how can we make a two query result combined together? So we have the following way to do. We can use union, we can use intersect, and you'll be able to see. So this is a set operation right now. So suppose this is a set, this is a set. So we can use union, and we can use intersect. This union is the same logic as we defined in relation algebra for the union operation. Intersect is the intersection, set intersection. Okay, so that's also the same. And the except is the difference, set difference. Remember we learned this, the minus sign. Okay, so it's called the except in SQL. Okay, so in order to do this, okay, the SQL standard require we apply the operation, have the same attributes, and the attribute appear in the same order. And if you take a look about this, this is exactly the same thing as I ask you, request you to do when you do relational algebra, right? So we need to have the same number of attributes. Each attribute pair must be matching. So they have exactly, so like remember we did the set operation, first name, last name, also need the first name, last name. So each pair must be exactly the same in order to do the operation. Okay. So that's the how they operate is the same as we covered in relational algebras. This is set operation. And you may ask what happened if default is bad, right? And we cover that. If you remember, how can we convert a bag into a set? we use distinct, right? So we can use distinct to convert her back into a set. And you can always use distinct in here and distinct in here. Then you can union them afterwards. So you can, because the result possible can be a bag, right? Unless depends on how you select, right? You know, so to make sure it's a set, eventually you can use a distinct to do that. So let's see. So this is a union, and so let me see. Union is, we take this, right? This part only show once. That's union, and intersect is this. Remember? Okay, except is the set difference. So say this is R, this is S, and except is this part. This is R minus S. So if this one except this means that's the first, okay. So R, see this is R, this is S, the result. So R except S. So this one will be except S, there will be R minus S, so there will be this part. So showing R but not in S. Okay, so that's the set operation here. And in SQL, we do allow something called back operation. And this part is not required in 134. I'm just quickly go over this in case you want to know. Okay, so again, you don't have any question in your assignment. You don't have any question in the exam that you have to use this union or except or intersect or. So what this one mean is you allow the bag to participate in union. And so when we have a bag union, you just simply including all the result from R and all the result from S. So R union all S, everything, okay, no duplicate, no, nothing need to consider, everything in input R, everything in input S, they will be in the output. So this is the easiest one ever for union all. And except all, okay, remember except is the difference, right? So what happened is if you have R, something appear, the same element appear X times, and for S, the other side appear Y times. How many times in the final output is X minus Y? Okay, so if this is a 10 times, this is 3 times, eventually 7 times appear in the final output for the same element. I intersect, if something appear like 10 times, the other 3 times, we take the minimum. So eventually in the output show 3 times. That's the logic for union all, except all, and intersect all. So that's the bag operation, just in case you want to know. Okay, so in order to do union, except, and intersect, we do need 2 sets, right? So that's the 2 query result. Then we can combine them together. Let's see a really interesting example here. And this is also the one kind of like help you to see what kind of situation I want to use those operations, right? So I produce some result and produce another set of result. I'm kind of like combining them certain way. You know, that's the times I see. We have project number that I only need project number, and that involve employee whose last name is Smith. Okay, so that's on Smith again, and then we want to see either a worker or a manager. So as a worker, Smith, that means the employee works on the project, right? Okay, remember we just finished that. And the manager, okay, so it can be a manager of the department that control the project. This is the one we just finished the exercise, right? So you can have a manager, and manager is the manager of the department, and the department controls the project. So you can see the first part, worker part, is one set, right? So if we can write a query to find out what are the satisfied table, right? The result table is a worker. And then the next part is I have a manager. And so this one, I want to add this or that, then I just union them. So logical wise, when you see things like this, that's a perfect case to do a union. And also when you do this, you can do problems separately. You can working on the first one, that's just one query, right? Then you work on the second one, that's another query, and you just combine them using union, that's all. Okay. So I probably should use another page so I have more space. Okay, so first of all, you can do either one, right? You can do the manager first, or you can do the worker first. It doesn't matter. So let me do the manager one since we just finished the exercise. Still remember how to do that, right? So let me write a query. So I do a select. And this is also the one we need to check union compatible, right? But this query book just ask the project number, nothing else. So we be able to do project number. And so we want to do the manager one first, right? So we have a project and that is controlled by a department, right? And then we have employee here. Okay, so in order to say the project controlled by the department, we do DNUM, go to D number, right? So this project controlled by the department. Department has a manager, right? So the manager, I want to locate this manager, this employee, because I need the last name. So I have to join with employee here. Right? And I know the last name of the employee. Smith. Okay, so to make sure, so I want to select the project number eventually. And to make sure it is a set. So let me just using distinct here. So that's guarantee I produce a set eventually. So getting the manager part then. Okay, so we have this. And then let me write another query, and this query is on the worker part. Okay. So the worker part is employee works on project, right? So we have project table. Okay. So how do we say employee works on project? So first of all, to join project we works on, we have P number equal to P and O, right? And I can work some with employee, that's ESSN equal to SSN, right? Okay, and the next one I need to do is the last name of employee, right? This one is Smith. Okay, so you see this is one separate query. And in order to make sure P number is distinct, so I want to make sure it's the set, so I put a distinct P number. And I check everything, no ambiguity is coming from only one table here. Okay, so now you see this is one query, this is another query. So they are exactly one single block each, right? So one block, another block. And so that's just what I did here, right? So this is one query, this is another query. We can use simply we'll just say unit. That's all. And at the end, put this. That's it. Okay, so some you will say, is this the right syntax? Yes. So you have to have one query, another query, and then we union them. This query itself can run by itself. This query can run by itself. So that's why they are not interfering with each other. So you see the employee, you see the employee. It's okay. You know, you don't need to worry about that because this whole thing is one separate query. And you just simply union one query result. You can think, but this is a table, this is a table. And then we union two tables, and eventually the final result is one table by union them. Okay. Oh, okay, let me move on to the next one. Okay, so we can couple things I want to cover here is first of all we can do calculations. So for example, I surely can do, so this query say employee works on project, right? And they works on this product X project. I want to show what will be there, what will be the effect of giving all employee 10% more salary, right? So first of all, I can retrieve salary like this. So you can see first, last, and salary, right? So definitely that's a query can be done. But not only that, the good thing is we can put a calculation. Say this is the 10% of 1.1 times this. In this one, you'll be to produce a result, right? So whatever initial salary get 10% more. So the query table will show that. And so that's one thing good. We can do calculations. So we don't have to always reflect the raw data retrieved. We can do, things like that. But another thing I want to show you is we can use as keywords in the select statement also. Okay? We have this, that's called the alias when we do in the from. Let me go back quickly. Here, so you can see something as. So this as using in the from, let's give another name to the table. And now we can do a similar thing here. And this as give another name to this column. So the column itself, since we did the calculation, it doesn't have any specific name anymore, right? So that's why if we use as, we can give a name to this table. So once we do this, by default result, we're going to have And okay, yes. So that's my column names. So you may ask, if I don't do ads, what will happen? So this is all depends on, if you don't do ads, then what will show up for this column is all depends on the DBMS product you use. So many of them, they just directly show this as a column name. Some of them, they just show empty things without the column. So when you try, you will see, when you type the query result, they usually show you a table result like this, and you will see the column names. And to give a good column name, you use as in order to handle any arithmetic operations. All right, an interesting question related to this. Are the query different or not? And think about what query can do, okay? Query is a read operation. So it's reading things from the database. So when you run this, it gives you the right number, 10% more, but whatever in the database, still the original salary. So after you run, the salary is still the same in the database. So if you run this again and again, the employee who worked for this project still the same salary. Okay, if we want to change the salary, okay, so if we want to really give them 10% more, we have to use update statement, because, okay, so query is a read operation, and update, insert, and delete operation, they are write operation. So it means they would possibly change the database values, depends on what kind of thing, update, insert, delete. So they are write operation. So it is safe to run this query many times without changing the value. But when you do update, make sure you're careful each time you run to get 10% more, right? So you run this 1,000 times, think about it. Okay. Okay, but anyway, this one also show you, you can use as to rename. Sometimes it's used for, for example, you do the union operation, you need the same name, attribute name, and you'll be able to use renaming to produce the result. Okay, and there are a lot of things related to string operations. And let me show you some simple ones. And this is like a substring pattern matching. So when we have a string, like in our schema, like address, for example, right? Name, we have those things all the time. So we can use a like comparison operator to do that. And in order to do something called a pattern matching, so we have basically two ways to do this. One is using this, and that one can give you arbitrary number of 0 or more. This is a case good when you know something, but not actually how many characters before. So for example, this one, I see address like, there's something possibly before Houston, and something also possibly after that. As long as they contain this, you can put this before and after, then we get this, right? So if you know this string, the last one will be TX, you don't have anything. So you don't have to put this, but this one means 0 or more. Another one is if we know exactly there, say for example, for social security number, I know the last 4 digit, and I also know the third digit is 1, then I'll be able to do this. So it gives you exactly the space that is empty, means, can be anything. And then this position must be 1, this position must be like that. And so there are also a lot of other things related to operator on string. Each DBMS, they have their own way to do, and when you use it, if you do complicated ones, go ahead to discover that. It can save you some of your effort to do to operate on strings. Okay, so now up to this point, we learn 3 clauses: select, from, and where, right? And remember, I mentioned that the result of a select, from, where give you a result that can be in any order, right? So like those, any, I try to show like this one, right? So this one can give you a result, and the last name, it can be alphabetical order, opposite order, or no order at all, can be in any order. So how can we control the order, right? Sometimes they did the order nicely, and that's actually beyond our course. Why sometimes they order for me, sometimes they don't. It's because underneath there are different algorithms to handle the query, and they may use sorting based. If the sorting base possibly are ordered already, but there's you don't see it as a user, you only give you a result. So how can you control the order? Then we added this one more. So this is a new clause, order by. Okay, so the order by clause allow you to specify in my final output what kind of thing I want to order them. So the logic is you need to pick attributes coming from here. Okay, it's not necessarily follow the order you have, like you dname last name, dname last name, first name. But however, it's the human's tendency, right? The reason you order them just because you wanted the result to be displayed nicely. So that's why usually we just follow the order, what we have here, but they must come in from here. Otherwise, you order something not even show, it doesn't make sense. Okay, so like this case, we do dname for descending order. So you can do a descending and ascending. Actually, probably just read this query first. Okay, so we want to order by the department in descending order, then with each department by last name, first name in ascending order, right? So you see, we ordered this by descending order here. And if we have a tie, okay, if we have a tie in this ordering, the tie is broken by the next one. And of course, anything, this is the main thing to have them, and the tie is broken by this. And if we have tie here, the tie is broken by the next level. And if in the next level, the very last level, you still have tie, then the order of the next thing, so there's another one, right? They are undecided. So you can also decide, for example, I only care about the name, show, and I don't even need this. Of course, you need this to answer this question, right? So if I ask you this question, you have to have it. But if they don't care about that, only the name, then we just order this way. And I can show you an example to help you to understand. Okay, so you remember we order by this first, and the tie is broken by the next one, and the tie, if any tie here, tie is broken by the next level. And let me just show this to you. Say I have a result of many departments, and so I have basically 2 departments in my result. One is EE, one is a triple E, one is a CSC department. So my result, okay, one thing before that, I want to let you know that when you do ordering, you have to, so this is, okay, so let me show this to you first. So I have, say, like 3 tuples. When we do ordering, so this one can be the first one, move to up, So this is 1, 2, 3, for example. So never to go to become the first tuple and then like that. So you have to move the whole tuple up. You cannot say I just move this attribute up and combine with the attribute here. That is not okay. Okay, so the order by doesn't do that. The order by take the whole tuple up or down or whatever position, right? So let's understand that one firstly important. Yeah, the whole tuple moving up and down. Okay, so let me see. So first of all, I have two departments. Since this is descending order, so I'm going to have EE. Any tuple with EE, they will show up first. And then CSC will show up. So of course, each of them, they have other attributes, right? So I will just take the tuples, first of all, order them by that. And we see a tie, actually, 3 of them, this is a tie, this is a tie. So within the 3 tuples, I'm going to reorder them to make the tie broke the tie by the next one. That's the last name. And this is ascending order. So that's why I say if I have a tuple of a chain, and that should be before date, right? Again, remember we move the whole thing up or down, right? Not an individual. So if I think about the 2 tuple like this with whatever attribute afterwards, I need to make sure this is before that because this is ASC. So I have that. Okay, and remember the ASC is default. So if you don't see anything, so if there's nothing in the requirement, say descending or ascending, then by default it's ASC. Also in the query, if you don't see ASC, you just say order by L name, then that's by default ASC. But DESC, you have to say it. Okay, so go back to this. So this is after that, right? Okay, so see if I have another chain here, then we have another tie. The tie is broken by the next level. But let me get a CSC one first. So CSC, say I have a brown, and I have another brown. Okay, I also see a tie here. So let me handle the next level. So say this is a tie. Okay, let me do the easy one first. So CSC, a tie, and the next one brown, both brown, so another tie, right? So last level, first name ASC. So first name, and let me see. So we have a Richard, and then we have a Zach. So ours, alphabetically, this should be R before Z. So that's why this is first, this is second. So this is this whole thing is one tuple. So originally, whatever the order, this one going to be before that. Okay, so then the next one we handle is this one. So they have some values here, and for chain, I have a tie. So I'm going to have here. And I have to have this one here, right? So now you see it's broken. And the date, say I have Patrick here. So this one doesn't matter. It has to be there just because this one tell this level already tell that's after that. So even this is, you know, A called AAA, right? Triple A as the name, still it has to be in this position for this particular one. Okay. All right. So this is the order by. Well, so I feel this is easy one. You should get points, okay, in your exams. So one more time. By default, it's an ascending order. So if I don't see anything, I say order by employee's last name, then you order by ascending order. Also in the order by class, you don't see anything, they by default is already. So if you say order by D name, comma, last name, first name, then everything is ASC. So if you're confused about this, the easy way, just always put DSC or ASC in the right position, then you will never be wrong, right? Okay, that's all for today.